Hello everyone, I'm Ankita Mahapatra and I have made this short video to describe my project Heart Rate Monitoring Device and Remote Data Logging for Embedded Systems EECE 6712 Spring 2014 under the guidance of Dr. Bashir Morshid. In simplistic terms, ECG is a record of electrical activity of heart and gives vital information about cardio health. This is how a typical ECG signal looks like with distinct P, Q, R, S, T sections. These peaks measured over a 60-second interval will give you the beats per minute or BPM. This is the basic layout of the board that I am using for signal capture. The electrodes measure the ECG signal and the potential is given to the analog front end as input. The green part shows you how the ECG signal travels from these electrodes to finally the Bluetooth transmitter. The next stage is the notch filter, followed by the low pass filter, the high pass filter, the amplification stage, and the Bluetooth transmitter, which transmits the data to a local PC for data analysis. The soul and heart of this system is PSOC3 CY8C38. Let's discuss each of these sections in details. The analog front end uses an instrumentation amplifier as shown in this schematic here. The IC used is ISL28270 with a gain of 26.5. The notch filter uses MCP 6002 with a notch frequency of 60 Hz to ensure that components corresponding to the line frequency doesn't corrupt the requisite signal. The low-pass filter has a cutoff frequency of 125 Hz and a gain of 1.619. The high-pass filter has a cutoff frequency of 0.15 Hz with a gain of 1. The amplification stage in my case had a gain of 3. The one to the left corresponds to EEG capture and the values given on the right in blue correspond to ECG. I had to change them because the amplitude of ECG is much higher than EEG, and if I use the same board I would have got a saturated signal. The final Bluetooth transmitter is a basic RN42 class 2 Bluetooth module. This is the board layout that has been designed using Allegro PCB editor. It shows you the layout of all the components. As for the electrode connection, one lead goes onto the blue vein on your wrist of your left arm, the second one goes to the wrist of your right arm, and for reference we stick another electrode to the mastoid, which is basically the heart bone behind your ear. Whatever signal is measured by the left arm goes to the positive end of the op-amp and the right arm sends its signal to the negative input of the op-amp. As you can see here, these two are the channels and this is the reference, and I'm not using this channel. This is how the board looks like. The golden things here are the pads where the components are populated. The technique to populate these are that you put a small amount of solder paste here, then you transfer your component and then you use a hot air current to solder it. I'm going to show a video of how a soldered board looks like. I have populated this completely. This is the PSOC, the Cypress PSOC that I mentioned before. That one is the instrumentation amplifier in the analog front end, and those are the leads. This is the Bluetooth module RN42. For transmitting your data, I'm going to zoom in so that you get an idea of the size of the components that I'm using. Let me flip this board over for you. On the back you see more components with a switch and also the slot where the memory card goes in. This is the output I observed at the final amplification stage with an input of 5 millivolts. You can see that the output is saturated because the input is too high within its range. Unfortunately, this is the only data I could obtain. Because of an unfortunate incident, my whole board got burnt out. But if you have any other questions that are related to this project, I would be happy to answer. Thank you.